Welcome back to another training video using the UK Electrical Simulator. In this video, we're going to continue from where we left off and extend our 3-plate lighting circuit by adding 2 more ceiling roses and 2 more one-way switches. We'll also use the meter probes and clamps to measure the voltage and current at different points in the circuit. Before we begin, let's quickly remind ourselves what we already have on the workspace. We have 1 ceiling rose, a one-way switch, and power supplied from circuit 5, which is protected by a 6 amp RCBO. When the switch is turned on, the circuit is complete and the 10-watt lamp is energized. There is one small change from the previous video. This time we have added an extra voltage meter. We now have 3 sets of probes, allowing us to monitor the voltage at all 3 ceiling roses. Before extending the circuit, let's also add a couple more room zones to represent the different bedrooms. The quickest way to do this is to highlight the existing room zone, then press Ctrl-C followed by Ctrl-V on the keyboard. This will copy and paste the selected zone and everything inside it. Press Ctrl-V again and a third zone will be added. To rename the new zones, simply double-click their titles and change them to Bedroom 2 and Bedroom 3. We now have 3 ceiling roses and 3 one-way switches, each one located in its own room. Because the zones were copied, the local switch wiring from the switch to the rose terminals for each room has already been duplicated, so all we need to do now is extend the neutral, the permanent line, and the earth from the first rose to the second and third. First, connect a neutral conductor from N3 on the first rose to N2 on the second. Then repeat the same from the second rose to the third. Next, connect a permanent line conductor from loop L2 on the first rose to loop L1 on the second. Then repeat that again from the second rose to the third. Finally, connect the CPC earth conductor between the earth terminals of each ceiling rose. Connect the meter 1 probes across the neutral and loop line terminals of the first rose. Do the same with the meter 2 and 3 probes on the second and third. Next, add the current clamps to the circuit. Place 1 clamp on the main permanent line conductor feeding the first rose from the consumer unit. Then place a clamp on each switched line conductor feeding the lamp. Set the clamp readings to milliamps by double-clicking on each of them. This gives us a clearer reading for small lighting loads. We can now energize circuit 5 and turn on the animation by pressing the A button on the consumer unit. When we switch on the first bedroom light, the lamp in bedroom 1 lights up, and we see a current of approximately 43.5 milliamps. That is exactly what we would expect for a 10-watt lamp on a 230-volt supply. At this stage, the clamp on the main feed to the circuit shows the total current for the circuit, while the clamp on the switched live to bedroom 1 shows the current feeding that individual lamp. Now let's switch on the second bedroom light. We now have 2 10-watt lamps operating, so we would expect the total current on the main feed to double. That would be 43.5 milliamps times 2, which equals 87 milliamps, and that is exactly what we see on the main feed clamp. Then, when we switch on the third bedroom light, we now have 3 10-watt lamps energized, so the total current becomes 43.5 milliamps times 3, which equals 130.5 milliamps. Again, this matches what we expect to see on the clamp feeding the permanent line into the circuit. One important point to understand is that the voltage remains at 230 volts across the neutral and permanent line terminals at each ceiling rose, regardless of whether the individual switches are on or off. That is because the permanent line loop continues through each rose all the time while the RCBO is energized. The switches do not control the permanent line at the rose itself. They simply control whether that permanent line is returned back to the lamp as a switched line. So even if the first bedroom switch is turned off, the second and third ceiling roses still have 230 volts present at their loop and neutral terminals. And even if all 3 switches are off, the permanent line and neutral are still present throughout the lighting circuit. That is one of the key points to understand with the 3-plate method. The ceiling rose contains both the permanent line loop and the switched line connection for the lamp, and those two must not be confused. I hope you've enjoyed this 2-part video series showing how the 3-plate lighting method is wired and how it behaves in operation. In the next video, we'll move on to the more modern two-plate method of wiring lighting circuits in UK homes. Please like, subscribe, and leave a comment below.